Process Safety Management, or PSM, is a set of standards from the Occupational Safety and Health Administration that requires employers to identify, evaluate, and control hazards associated with highly hazardous chemicals. No two workplaces function in the same way or have the same physical and social environment. Similarly, each organization has its own unique set of challenges and safety concerns. This requires a comprehensive approach to addressing organizational safety issues. Process Safety Management provides a blueprint for implementing a thorough methodology for maintaining safety standards. The Occupational Safety and Health Administration introduced the Process Safety Management Requirements, or PSM, in 1992 in response to a series of catastrophic incidents. Process Safety Management is a regulation put in place by the OSHA that looks at all processes that involve handling, using, storing, moving, or manufacturing highly hazardous chemicals. Process Safety Management was designed as an analytical tool that helps companies prevent harmful highly hazardous chemicals from being mishandled or released. The OSHA regulation for process safety management is 29 CFR 1910.119, a standard that requires employers to create a comprehensive safety program for facilities that handle or store hazardous chemicals above specific thresholds. The main objective of process safety management is to prevent unwanted discharges of hazardous chemicals, especially into areas that could endanger employees and others, to the risks associated with the chemicals. An effective process safety management program requires a comprehensive methodology to evaluate the entire chemical process. A process safety management program is critical for any organization that has highly hazardous substances on site. It is intended to oversee the reliability of operating processes and systems for the handling of hazardous materials by applying strategic design standards, engineering, and working methods. Though process safety management is directed at organizations with hazardous chemicals, the basic principles are applicable to any business safety program. The core concepts have universal application. Organizations that do not have hazardous materials will still benefit from processing safety information and analysis, training personnel, having employee involvement, and so on. PSM is important because it systematically prevents catastrophic accidents, protects employees and the public from hazardous chemicals, ensures regulatory compliance, and safeguards a company's reputation and finances. It is a mandated framework by OSHA for handling highly hazardous chemicals to prevent explosions, fires, and toxic releases through procedures like hazard analysis, employee training, and mechanical integrity programs. Some reasons PSM is important include: prevents major accidents. PSM provides a systematic approach to identify and control hazards before they lead to catastrophic events like explosions or toxic releases. Protects people and the environment. It is crucial for safeguarding employees, neighboring communities, and the environment from the potential consequences of chemical releases. Ensures legal compliance. PSM is a legally required standard by OSHA for industries that handle highly hazardous chemicals, and non-compliance can lead to penalties and legal consequences. Reduces costs. By preventing accidents, PSM helps avoid the significant financial costs associated with incidents, such as medical expenses, lost profits, property damage, and compensation claims. And improves business operations. It fosters a strong safety culture and enhances overall operational efficiency by improving coordination across departments, boosting employee morale, and building a reputation for responsible operation. The OSHA regulation contains 14 elements that encompass the entire range of management's process safety requirements. They include: 1. Employee participation. 2. Process safety information, or PSI. 3. Process hazard analysis, or PHA. 4. Operating procedures. 5. Training. 6. Contractors. 7. Pre-startup safety review, or PSSR. 8. Mechanical integrity, or MI. 9. Hot work permit. 10. Management of change, or MOC. 11. Incident investigation. 12. Emergency planning and response. 13. Compliance audits. And 14. Trade secrets. Now let us look at these elements in more detail. PSM employee participation is a requirement for companies to actively involve employees, including operators and maintenance staff, in all aspects of their process safety programs. This involves creating a written plan for involvement, collaborating with employees on tasks like process hazard analyses, and providing them with access to safety information and documents. The goal is to ensure a two-way flow of information between management and employees to prevent chemical releases by integrating their knowledge and experience. The key aspects of PSM employee participation are: written plans. Employers must create a formal, written plan that outlines how employee participation will be implemented and managed. Collaboration. Employees, or their representatives, must be involved in the development and maintenance of key PSM elements. This includes performing and creating process hazard analysis and other related documents. Information access. Employees must have access to all relevant PSM information, such as process hazard analysis, process safety information, and other documents developed under the PSM rule. Two-way communication. The process encourages a dialogue where employees can report hazards, provide input on safety procedures, and participate in incident investigations, rather than just following orders. Involvement in all aspects. Employees should be involved in a variety of activities, including developing program goals and procedures, verifying the accuracy of process safety information, participating in PHA teams, reviewing and updating operating procedures, evaluating training programs, and participating in incident investigations. Process safety information is the foundational, written data required by OSHA's PSM standard that details the hazards of a process and the necessary information for its safe operation. It includes data on the highly hazardous chemicals used, the technology of the process, and the equipment involved, serving as the basis for risk analyses and safety procedures. This comprehensive information helps ensure that employees understand the risks and that safety controls are adequate to prevent catastrophic incidents. Here are some key aspects of process safety information. Chemical hazard information including toxicity, permissible exposure limits, and physical data such as flammability, reactivity, and corrosivity. Thermal and chemical stability data. Information on the hazardous effects of inadvertent mixing of chemicals. Safety data sheets are often part of this information. Technology information including a block flow diagram of the process and the process chemistry. Maximum intended inventory of chemicals. Safe upper and lower limits for process parameters, such as temperature, pressure, flow, and composition. Consequences of deviations from established limits. And equipment information including materials of construction, piping and instrumentation diagrams or P&IDs. Safe upper and lower limits for equipment and process parameters. Information on pressure relief systems, emergency pressure control, and other safety systems. A process safety management process hazard analysis is a systematic, team-based evaluation of a chemical process to identify potential hazards and recommend safeguards to prevent the release of hazardous substances. It examines what could go wrong by looking at deviations from intended operations, assessing their causes and potential consequences, and identifying existing controls. PHAs are a key requirement of OSHA's PSM standard for facilities handling certain highly hazardous chemicals. The key components of a PHA include team-based evaluation, a multidisciplinary team with expertise in engineering, operations, and safety who conducts the analysis. Hazard identification. The process identifies potential hazards, including those from equipment failures, human errors, and external events like weather. Deviation analysis. Teams look for deviations from the intended design or safe operating limits and analyze their potential causes and consequences. Safeguard assessment. Existing safeguards, or controls put in place to prevent or mitigate hazards, are identified and evaluated for their effectiveness. Risk ranking. The risk is often ranked both before and after safeguards are considered to understand their impact. And recommendations. The analysis results in a list of recommendations for corrective actions to reduce risk. The common PHA methodologies are what-if analysis, a brainstorming approach where teams ask hypothetical what-if questions to uncover hazards and consequences. Checklist, a structured method that uses a predefined list of potential hazards to guide the analysis. HAZA, or hazard and operability study, a systematic method that examines how process parameters might deviate from their design intent. And fault tree analysis, a top-down approach that starts with a potential failure and works backward to identify its contributing causes. PSM operating procedures are written, step-by-step instructions that guide employees on how to safely perform tasks in a process involving highly hazardous chemicals. These procedures must clearly describe the steps for activities like starting up, shutting down, and emergency operations, ensuring consistency and reducing the risk of incidents and deviations from safe operating parameters. They are a core part of a larger system to manage chemical process hazards and are required to be readily available for employees. The key components of PSM operating procedures are task-specific instructions. They provide clear, written instructions for performing specific activities, such as operating pumps, cleaning reactors, or handling drums. Safety focus. The procedures are designed to reduce deviations from intended actions, ensure consistent performance, and maintain safety during all phases of operation. Emergency procedures. They must include instructions for handling potential emergencies, including both normal and emergency shutdown procedures. Availability. Procedures must be readily accessible to employees during their work shifts for reference and review. Change management. When changes are made to the process, equipment, or technology, the operating procedures must be updated to reflect the changes and their impact on safety. Consistency. By having written procedures, employers ensure that tasks are performed consistently, which improves safety and reduces the likelihood of incidents. And employee expectations. They clarify employee responsibilities and expectations for performing their jobs safely. PSM training describes instruction on process safety management, an OSHA standard for facilities using highly hazardous chemicals. The training covers identifying, evaluating, and controlling process hazards to prevent catastrophic incidents like fires, explosions, or toxic releases. Key elements include training on operating procedures, emergency shutdowns, and the specific safety and health hazards of a process, with regular refresher courses required. The core components of a PSM training program are hazard identification and risk assessment. Employees learn to identify and assess the risks associated with highly hazardous chemicals and processes. This includes understanding the difference between personal safety and process safety. Operating procedures. Training provides a detailed overview of how to safely operate the process, including emergency shutdown procedures. Emergency operations. Employees are trained on emergency operations, including what to do in case of an incident. Process hazard analysis. Training may include a thorough process hazard analysis to identify and evaluate potential hazards. Management of change. The training covers the necessary requirements for managing changes to a process to control hazards. Mechanical integrity. Employees learn about the importance of maintaining the integrity of equipment to prevent failures. An incident investigation. Training may include lessons on how to conduct and learn from incident investigations. PSM contractors are external workers hired by facilities that use highly hazardous chemicals, and they are subject to the facility's stringent safety requirements to prevent catastrophic releases. This includes being integrated into the facility's safety protocols through pre-project safety planning, site-specific training, clear communication of hazards, and continuous monitoring of compliance with rules like lockout-tagout and hot work permits. The goal is to ensure that the contractor's work doesn't compromise the safety of the process, the facility's employees, or themselves. The role and responsibilities are performing critical work. Contractors are often hired for maintenance, repairs, turnarounds, or major renovations on or near a PSM-covered process. Adhering to facility safety. They are required to follow the host facility's specific safety rules and procedures, which can include lockout-tagout, confined space entry, and hot work permits. And following a safety plan. Contractors are responsible for preparing and carrying out their own safety plans, which must be followed by their staff throughout the project. The safety integration and requirements include training. Contractors must be trained on the known potential fire, explosion, or toxic release hazards of their work and the specific process. Communication. The facility must inform contractors of the hazards associated with their work area and process. Compliance. Contractors must ensure their staff is trained to perform their jobs safely and that safety protocols are followed, as outlined in OSHA's PSM standard in their own companies and the host facility's plans. And reporting. Contractors must have a system for employees to report all accidents, injuries, and near misses to their foreman, who then notifies the appropriate company contact for investigation. A PSM pre-startup safety review is a mandatory, systematic inspection to confirm that all safety measures are in place before a new or modified process system is started. It verifies that the new or modified equipment is installed correctly, the system is mechanically sound, operating procedures are in place, and all safety requirements and training are met. A PSSR helps prevent accidents and maintain compliance with regulations like OSHA. The key components of a PSSR include construction and equipment. Verify that all equipment is installed according to design specifications and safety standards. This includes checking the physical installation, safety labeling, signage, and system connections. Procedures. Confirm that new or updated safety, operating, and maintenance procedures are in place and documented. Hazard analysis. Ensure that any necessary actions from a previous process hazard analysis have been completed and implemented. Training. Confirm that all employees involved in the process have received the necessary training. Documentation. Review all required documents, such as permits and certificates, to ensure all conditions are met. System checks. Perform a field inspection or site visit to verify instrument calibration, control functionality, and the readiness of emergency and fire suppression systems. And issue resolution. Any identified issues or gaps are documented, and corrective actions are assigned. A system cannot start up until all critical safety issues are resolved. PSM Mechanical Integrity is a systematic program to ensure that critical process equipment is designed, installed, inspected, tested, and maintained to prevent accidental releases of hazardous materials. It includes written procedures, employee training, and documentation for equipment like pressure vessels, storage tanks, piping, and relief systems. The goal is to maintain the integrity of these fixed assets to prevent equipment failure and ensure safe, reliable operations. The key components of a PSM Mechanical Integrity Program include 1. Written procedures. Detailed, step-by-step instructions for inspection, testing, and repair of equipment. 2. Equipment covered, such as pressure vessels and storage tanks. Piping systems. Relief and vent systems and devices. Emergency shutdown systems, controls, sensors, alarms, and interlocks. And associated hardware like valves and fittings. 3. Inspections and testing. Regular inspections and tests are performed according to manufacturer specifications and industry standards to identify deficiencies. 4. Corrective actions. Any equipment deficiencies found that are outside of acceptable limits must be corrected before the equipment is returned to service. 5. Documentation. All inspections and tests must be documented, including the date, inspector, equipment identifier, and a description of the results. And 6. Training. Employees involved in the program must be trained on the process hazards and the procedures applicable to their job tasks. A process safety management hot work permit is a formal document used to control activities like welding, cutting, or any other spark or flame-producing task in a facility that handles hazardous materials. It requires a documented process to ensure the area is safe before work begins, verifies fire prevention and protection measures are in place, and details specific safety requirements, responsibilities, and the duration of the work. The permit acts as a checklist to mitigate the risk of fire or explosion by confirming hazards have been identified and controlled. The key elements of a PSM hot work permit include: work description. Details the location, nature, and duration of the hot work. Permit holder. Identifies the authorized individual performing the work. Area inspection. Confirms the work area has been inspected for flammable or combustible materials and that fire prevention measures have been implemented. Safety precautions. Specifies safety measures like removing combustibles, covering floor openings, providing fire extinguishers, and assigning a fire watch. Fire watch. Ensures a trained individual is present during and after the work to monitor for fires. And authorization. Requires a signature from the permit issuing authority, verifying all conditions have been met. PSM management of change is a mandatory, written procedure for evaluating and authorizing all changes to processes, equipment, technology, or procedures to prevent new hazards or increased risk. It requires a thorough assessment of the technical reasons for the change, its impact on health and safety, and authorization before implementation. Employees must be informed and trained on the change before it is put into effect. The key requirements for PSM management of change include: documentation. All changes, including temporary ones, must be documented with their technical reasons and impact on health and safety. Technical evaluation. Changes must be reviewed for their potential impact on safety, risk, and the need for new or updated procedures. Authorization. A formal authorization process must be followed to approve changes before implementation. Employee training. Affected employees and contractors must be trained on the change before the process is started or the affected part is put into service. Communication. All personnel affected by the change must be informed of it. And record keeping. Records of all changes, approvals, and training must be maintained for audits. The types of changes that trigger management of change are: physical alterations to equipment or facilities, changes to operating procedures, changes in the use of chemicals, new equipment or technology, changes to maintenance or testing procedures, and temporary changes, such as moving equipment. A process safety management incident investigation is a systematic process to determine the root cause of an incident, such as an accident or near miss, and to prevent future recurrences. It involves investigating any event that caused a release of a highly hazardous chemical, or could have, starting promptly after the incident occurs. The process requires creating a detailed report of the incident, identifying contributing factors, and making recommendations, all while focusing on system flaws rather than assigning blame. The key aspects of a PSM incident investigation program are: prompt start. Investigations must begin as soon as possible, with the requirement to start within 48 hours of the incident. Systematic approach. The investigation is a structured process that examines the facts and circumstances to uncover the root causes. Diverse team. A diverse team, including managers, safety officers, technicians, and engineers, should be assembled to conduct the investigation. Data collection. Investigators gather information from various sources, including employee interviews, equipment manuals, training records, and photos. Root cause analysis. The goal is to identify the underlying reasons for the incident, not just the immediate cause. Tools like the 5 Whys technique and fishbone diagrams can be used to help with this analysis. Report generation. A report must be produced that includes the date of the incident, a description, contributing factors, and recommendations for corrective action. Corrective actions. A system must be in place to promptly address and document the resolutions for the recommendations. Employee communication. The findings and recommendations are reviewed with all affected personnel, including contractors where applicable. Record keeping. Incident investigation reports are retained for a specified period, often 5 years. And no blame culture. A key principle is to focus on the system and management failures that led to the employee's actions, rather than blaming the individual. PSM emergency planning and response involves creating and documenting detailed procedures to manage the effects of a catastrophic event, such as a chemical release or fire. It requires a written emergency action plan that includes alarm systems, evacuation routes, emergency contact information, and specific procedures for different scenarios to minimize harm to people, property, and the environment. Regular training and drills are essential to ensure employees can respond effectively. The key components of PSM emergency planning and response include risk assessment. Identify potential hazards and likely emergency scenarios, such as fires, explosions, or toxic chemical releases. Written emergency action plan. A detailed, written plan is required, especially for facilities with more than 10 employees, to outline how to respond to emergencies. The plan should include emergency procedures for each scenario, a system for reporting emergencies and activating the alarm, contact information for employees who can provide more information about the plan or their duties, designated evacuation routes and assembly points, and emergency personal protective equipment requirements. Training and drills. Employees and contractors must be trained on their roles and the procedures outlined in the plan. Evacuation drills should be conducted at least once a year to test the plan's effectiveness. Alarm systems. Facilities must have an employee alarm system that uses a distinctive signal for each type of emergency. Coordination with external agencies. The plan should include procedures for coordinating with local emergency responders, like the fire department, for more severe events. And documentation. Written documentation of the plan, training records, and any changes to the plan is a regulatory requirement. A PSM compliance audit is a periodic, systematic review to verify that a facility's safety program is effective, compliant with regulations like OSHA 1910.119, and properly implemented. The audit involves gathering documentation, conducting on-site inspections, interviewing personnel, and reviewing findings to identify gaps and recommend corrective actions, with the required frequency of at least every 3 years. The key components of a PSM compliance audit are preparation. This involves defining the audit scope and gathering all relevant documents, such as previous audit reports, incident investigations, and management systems. On-site assessment. Auditors will conduct facility walkthroughs, observe operations, and interview employees to verify that documented procedures are being followed in practice. Documentation review. A detailed examination of key documents is performed, including a process hazard analysis, operating procedures, training records, and mechanical integrity records, to ensure they are accurate, complete, and aligned with the regulations. Gap analysis. The audit identifies any shortcomings or discrepancies between the company's practices and the requirements of the PSM standard. And reporting and corrective action. A comprehensive report is prepared detailing findings, non-compliance issues, and recommended corrective actions. The process also includes tracking these actions to ensure they are implemented effectively. In OSHA's Process Safety Management Standard, trade secrets are confidential business information that provides a competitive edge, such as formulas, processes, or designs. While companies must protect these secrets, they are required to provide employees with access to all necessary information to perform their jobs safely and comply with PSM regulations, though confidentiality agreements can be used. The following constitutes a trade secret in PSM. Confidential information. Any information a company uses to gain a competitive advantage. Not public knowledge. The information must be secret and not generally known to the public or the industry. Examples include things like unique manufacturing processes, proprietary tools, chemical formulas, recipes, or designs. PSM requires the following related to trade secrets. Employee access. Despite being a trade secret, employers must provide the necessary information to employees responsible for tasks like performing a process hazard analysis, developing operating procedures, and conducting incident investigations. Safety over secrecy. The PSM standard prioritizes safety, ensuring that proprietary status does not prevent employees from accessing the information they need to work safely. And confidentiality agreements. Companies can use confidentiality or non-disclosure agreements, or NDAs, to protect the information when sharing it with employees, as described in the PSM regulations. Deploying process safety management involves a systematic approach using the 14 key elements. The core elements of PSM deployment are leadership and employee involvement. Secure strong leadership commitment, with top management signing off on policies and visibly supporting safety. Establish employee participation through clear communication channels and encourage open reporting of hazards. Information and analysis. Ensure all employees have access to essential process safety information, including chemical hazard data, equipment design, and operating limits. Conduct a rigorous process hazard analysis to identify and evaluate potential risks. Procedures and training. Create and follow consistent, well-documented operating procedures for all phases of operation, including startup, normal operation, and shutdown. Provide comprehensive training for all employees on safety procedures, hazard recognition, and emergency response. Use tools like VR simulations for enhanced training. Mechanical integrity and change management. Implement a mechanical integrity program to track and ensure the safety and proper functioning of critical equipment. Establish a robust management of change process to review the safety impact of any modifications to processes, chemicals, equipment, or facilities. Emergency preparedness. Develop and regularly update comprehensive emergency preparedness and response plans. Conduct regular drills to test the effectiveness of emergency response procedures. Incident management. Implement a systematic process for investigating all incidents and near misses, including detailed root cause analysis. Use automated reporting and analytics to identify patterns and prevent recurrence. And compliance and audits. Conduct regular compliance audits to ensure the PSM program meets all regulatory and internal requirements. Ensure proper documentation is maintained for all PSM elements. Process safety management works to prevent unwanted discharges of hazardous chemicals, especially when it could endanger employees or other personnel operating in or near the work area. A process safety management program involves implementing comprehensive techniques to evaluate the entire chemical utilization practice. A rigorous process safety management program is critical for any organization that has highly hazardous substances on site. We hope you found this training valuable. Please click the subscribe button to access additional food shore training videos.